All right, we have part one of our final exam review for 118. So we'll start with an expression here, m squared plus 7m plus 1. And we'll evaluate this expression when m equals -3. You want to make sure you use parentheses for your substitution. So here we have parentheses, -3, close parentheses, and then our squared plus 7 parentheses, -3, close parentheses, and then plus 1. Now, where people oftentimes forget to put the parentheses or just don't do it is where you have the -3 that's being squared. So please don't give me lazy algebra. Use those parentheses for your substitution. So now we're squaring the -3. So that gives us +9, because remember, if you're squaring the -3, that means -3 times -3, which is +9. All right, so that gives us +9 plus 7 times -3, it's -21 plus the 1. Then next, I like to add my 9 and my 1 first. So that gives me 10 plus the -21. And then opposite sign subtract. That's going to give us -11 for our final answer. All right, next we have evaluate the expression when c equals 4 and y equals -2 for -c plus 5y. Okay, so when we do our substitution, we have negative and then parentheses for where c would be. And then c is 4. And then plus 5 parentheses, and y, we're substituting -2. All right, so we have multiplication, so 5 and then -2, so that gives us -4 plus -10. So we're adding to negative numbers, same sign, add, keep the sign, so that gives us -14. All right, we're given a function rule, y equals -4x plus 3. So fill in the table. So if x is -2, all right, so we have -4 parentheses, -2 plus 3. So that gives us 8 plus 3, which is 11. Next, -4 times 0 plus 3. So that gives us 0 plus 3, which is 3. Now for 2, -4 parentheses 2 plus 3. So that gives us -8 plus 3. Opposite sign subtract, keep the sign of the bigger number. So we have -5. And then -4 parentheses 4 plus 3. So that gives us -16 plus 3. Again, opposite sign subtract. Keep the sign of the bigger number. So we have -13. All right, number 4. All right, we have our equation. 3w plus 4 equals 6w plus 19. I'm going to put my variable terms on the right side. So I'm going to subtract 3w on each side. So that's going to give me 3w minus 3w is eliminated. And then I get 4. Oops. I get 4 equals 6w minus 3w is 3w, and then bring down the plus 19. All right, I'm going to put my constants on the left side, so I'm subtracting 19 on each side. So 4 minus 19, or in other words, we want to do the 19 minus the 4, so that gives us -15 equals 3w, and then divide both sides by 3. So that's going to give us -5 is equal to 1W. All right, and it's probably a good idea to check your answer here to make sure is -5 a solution. So we have 3 times -5 plus 4. Is that equal to 6 times -5 plus 19? Well, let's see. 3 times -5 is -15 plus 4. So that -15 plus 4 gives us -11. On the right side, we have 6 times -5 plus 19. So that's -30 plus 19, which again gives us -11. So we do get a true statement when we substitute our solution back into the original equation. So that must mean -5 is a solution. All right. Oh, it looks like my numbering is off a little bit. Let's fix that. This is number 5. All right, we have used the distributive property to remove the parentheses. So we have -3 parentheses, -2v minus y plus 3 close parentheses. So one, notice that there is no equal sign. So we're not solving for a variable. The best we can do is just simplify the expression and then we stop. So in this case, we're distributing the -3 across what's inside a parenthesis. So that's going to give us -3 times -2v, which is positive 6v. Then we have -3 multiplied to the minus y, so that's going to be plus 3y. And then -3 times positive 3, so that's going to give us -9. And that's it. We cannot simplify any further. Remember, in order to simplify our expression here, you add and subtract like terms, and like terms, we can see we have to have the same variables with the same exponents. So we're done here because we don't have any more terms that have the same variables and same exponents. Question 6, solve for y. Okay, so we have 2y plus 40 equals, and then we have -2 parentheses, y minus 6 close parentheses. So we know we have to distribute the -2 on the right side. Don't forget to distribute that -2 to both the y and the -6. So we get -2y plus, because of the negative times the negative, 12. All right, now, please show your work here. Don't try to do this in your head, because here where you have the 2y and the -2y, oftentimes students will mess that up and eliminate that mentally without showing the work, and this does not eliminate. So I'm going to add 2y to each side. And so we can see here, column by column, 2y plus 2y is 4y. That does not eliminate. Bring down the plus 40. The minus 2y and the plus 2y is eliminated, and bring down the 12. Okay, now I'm also going to subtract 40 on each side. So we get 4y. The 40 minus 40 is eliminated, equals 12 minus 40. So that's really, do the 40 minus 12. So that gives us 28. Keep the sign of the bigger number. So that's, keep the sign of 40. So that gives us -28. Divide both sides by 4. Y equals -7. All right, we have here 7 parentheses x plus 4 close parentheses equals -2 parentheses 4x minus 7 close parentheses plus 9x. So let's begin by simplifying, the right side. So the right side, we're distributing the 7 across the x plus 4. So that's going to give us 7x plus 28. All right, on the right side, we're distributing the -2 across the 4x and the -7. So that's going to give us -8x. Plus 14. And then just write the plus 9x. We're not distributing to the 9x because that's not in parentheses. Okay, now on the right side, we can simplify further because the -8x and the plus 9x are like terms. So that combines to 1x, and then bring down the plus 14. And on the left side, I'll bring down the 7x plus 28. All right. Let's subtract x on each side. And why don't we go ahead and subtract 28 on each side? We'll do this all in one step. So 7x minus x, that's 6x. 28 minus 28 is eliminated. -x minus x is eliminated. And then 14 minus 28 is -14. All right, let's divide by 6 on each side. We get x is equal to -14 over 6, which reduces to -7 over 3. All right, write an inequality for the graph shown below. Use x for your variable. So we have a solid circle at 2, and we're going to the left of the number line. We're getting lower. So x is going to be less than or equal to, because of the solid circle, 2. All right, question 9. Here we're writing a compound inequality for the graph shown below. Use x for your variable. All right, so in this case, this is a compound inequality for and, which is also known as an intersection. So we're going to use the shortened way of writing an intersection. So we know x is going to be between two numbers. So it's between 7. So that's just going to be less than 7. Here we have greater than or equal to 0. So the way that it's read, we say 0 less than or equal to x, which is less than 7. All right, question 10. We have -5y greater than -20. So we're going to divide each side by -5. So therefore, we know since we're dividing both sides by 5, we need to flip the symbol, and we get 1y is less than 4. All right, and just for practice, we can just do a sketch of the graph. If it's 1y is less than 4, that will be an open circle at 4, and we're shading to the left. All right, question 11. We have here -4v minus 25 is greater than 2v plus 17. So first thing I'm going to do, I'm going to add 4v to each side. So that's going to give me -4v plus 4v is eliminated. Then I have the minus 25 greater than 6b plus 17. All right, subtract 17 on each side. So we have negative 25 minus 17, same signs, add them. So we get negative 42 is greater than 6b. Divide both sides by 6. All right, so negative 42 divided by 6, and we get negative 7 is greater than, and then 1b. All right, question 12. You want to remember to, you have here absolute value 6y plus 9 equals 3. Make sure you write your two equations. So one equation is 6y plus 9 equals 3. The second equation is 6y plus 9 equals negative 3. Notice I am not writing the absolute value bars anymore because the equivalent of this one equation are the two equations that I've written without the absolute value bars. So here we go. Now we're going to solve, subtract 9 from each side. I'll do this for both of them. So we have 6y equals negative 6, and then we have 6y equals negative 12. Divide by 6 on each side. So we have 1y equals negative 1, and then we have 1y equals negative 2. So there are our solutions. All right, question 13. Here we have negative 5 and then the absolute value bar, u plus 4 absolute value bar equals negative 55. Now you might be tempted to say this is no solution, but you cannot make that decision until you have the absolute value expression isolated, and we do not at this point. First, we need to divide both sides by the negative 5. So that gives us the absolute value of u plus 4 equals positive 11. At this point, the absolute value expression is isolated and it's equal to a positive number. So indeed, we are going to have a solution. Now we write our two equations, which are u plus 4 equals 11 and u plus 4 equals negative 11. So I'm going to subtract 4 on each side. And that gives me u equals negative, I'm sorry, not negative, u equals positive 7. And then on the other side, we get u equals negative 15. So we have u equals 7 and negative 15. All right, here we have graph the solution to the inequality on the number line. So we have the absolute value of u is less than or equal to 5. Now remember, this is a compound inequality and it's less than or equal to. So this is going to be an and or an intersection. So this turns out to be u is less than or equal to 5 or greater than or equal to, and greater than or equal to negative 5. All right, if you write it separately, we're saying u is less than or equal to 5 and u is greater than or equal to negative 5. Notice how when we write the second inequality, we flip the symbol and flip the sign of that expression on the right, or in this case, it's just one number on the right, negative 5. So we have negative 5, positive 5, and there we go. All right, now for 15, we have absolute value of 5x plus 5 less than or equal to 15. So again, compound inequality and we can write it. We have 5x plus 5 is less than or equal to 15, greater than or equal to negative 15. So it's just quicker to write it this way, I think. And now when we solve this, we want to remember that this is actually two inequalities. So we remember if we subtract 5 from this middle, we got to subtract 5 from the right and from the left stem. So that gives us negative 20 is less than or equal to 5x, which is less than or equal to 10. Then divide both sides by 5. So we have negative 4 is less than or equal to x, which is less than or equal to 2. All right, so we have negative 4, positive 2. There's our graph. All righty.